Hi dear students, this particular class we are going to discuss about conic section. Why we are calling it as a conic section? Because either parabola or ellipse or hyperbola or a circle, these are all sections of a cone. You can observe this is a double napped cone, that means two cones joined like this. This is the axis of the cone. This is, let us imagine this is a plane. A plane is cut by this cone. Now in such a way, this axis is perpendicular to the plane. In that case, the cross section we are getting a circle. Same, this plane is cut by a plane with some inclination, inclined to an angle alpha with axis. Then you will get ellipse. The same plane is cut by the either side of the cone, that means this plane is parallel to the axis. Then this portion, upper portion, lower portion, both the portions are possible, that we are getting as a hyperbola. Whereas in this we will get another one which is called a parabola. So that's why either circle or parabola or ellipse or hyperbola, these are the sections of a cone. That is the reason we are calling it as conic section. Actually, what is the definition of a conic section? All of you observe here, it's a fixed point. Let us say this one as S, and this is a fixed line. A point is moving in such a way. Let us say this point is a moving point. We are calling this one as x1 y1. A point is moving in such a way, its distance from a fixed point, that means SP, its distance from a fixed line. So ratio of the distances for this moving point, from a point P x1 y1, distance to a fixed point, distance to a fixed line. Distance is nothing but the perpendicular distances. These two distances ratio is constant, that is SP by PM is equals to constant. Then the locus of a point P is called conic. Okay, the point is moving in such a way, its distance from a fixed point always bears a constant ratio to its distance from a fixed line. So the fixed point is called focus. We are calling this fixed point as a focus, and this fixed line we are calling it as directrix. Fixed line is called directrix. This constant ratio is called eccentricity, that is generally denoted with E. Eccentricity, that is equals to E. If the value of E is equals to 1, the locus of a point P is a parabola. If the value of E less than 1, the locus of P is an ellipse. If E is equals to 1, the locus of P is a parabola. If E less than 1, the locus of P is an ellipse. In case of E more than 1, the locus of P is hyperbola. Especially because E value more than 1, I am saying. Suppose the value of E is equals to root 2. Root 2 value is also more than 1. So E value is equals to root 2. Then the locus of P we are calling it as rectangular hyperbola. Rectangular hyperbola. So the point P is moving in such a way, its distance from a fixed point always bears a constant ratio to its distance from a fixed line. Fixed point we are calling it as a focus, fixed line we are calling it as a directrix, and the constant ratio we are calling it as eccentricity. If the constant ratio is equal to E, parabola. If the constant ratio E less than 1, the locus of P is an ellipse. If the constant ratio E is more than 1, then the locus of P is an hyperbola. Especially in E is equals to root 2, the locus of P is a rectangular hyperbola. Now here we are going to discuss different ideas in this conic section. As we told, it is a fixed point, we are calling it as a focus, and this is a fixed line, we are calling it as a directrix. Here is a moving point P, x1, y1. So as we discussed, SP divided by PM, that ratio is always constant. Now what I am doing is a line passing through focus and perpendicular to the directrix. This is a line passing through the focus and perpendicular to the directrix. We will call this one as axis of the conic section. Now we are saying that this is a moving point. Px1 y1 is a moving point. Definitely the point Px1 y1 lie on the conic, because this point is a moving point. Anywhere we can take here. Okay. So where the conic meets the axis, the point of intersection of conic and axis. So this intersection point we are calling it as vertex. Okay. At the same time, you see this is a chord of the conic section. A chord passing through focus. If the chord is passing through focus, we will call it as focal chord. A chord passing through focus is called a focal chord. At the same time, you can observe one more information here. What is the speciality of this line? This is a chord. The speciality of this chord is parallel to the directrix. The speciality of this chord is perpendicular to the axis. The speciality of this chord is parallel to the directrix, or we can say perpendicular to the axis. Now this particular chord we are calling it as double ordinate. This is also a double ordinate. Double ordinate is a chord parallel to the directrix. Double ordinate is a chord perpendicular to the axis of the conic. So what is the speciality of this double ordinate? This double ordinate is passing through focus. This double ordinate is passing through focus, which we will call it as latus rectum. A double ordinate passing through focus is called latus rectum. Now let us say one end of the latus rectum is equals to L, the other end of the latus rectum is equals to L dash. So this is, at the same time, we are saying this is a point we are calling fixed point, yes, and Px1 y1 is any point on the conic. Any point on the conic. Maybe it is a parabola, maybe hyperbola, maybe ellipse. Px1 y1 is a point on the conic. Now the distance between the point Px1 y1 and focus, this distance is called focal distance. These are the different points. The first one is principal axis of a conic section. What is the principal axis of a conic section? A line passing through focus and perpendicular to the directrix is called the principal axis. The next one is a chord. This chord is parallel to the directrix. Then we will call it as a double ordinate. A double ordinate passing through the focus is called latus rectum. A chord. This is a chord. A chord passing through focus. A chord passing through focus is called a focal chord. And we are calling this one as focal distance. SP is called focal distance. Px1 y1 is any point on the parabola and S is the focus. Distance between S and P is called focal distance. So these are the few ideas regarding conic section. Now we are assuming this fixed point as a focus, that is equals to alpha comma beta, and this fixed line we are taking it as AX plus BY plus C is equal to 0 is a fixed line. According to the definition of a conic section, SP by PM is equals to E. This is the perpendicular distance PM and this is SP. So from a point Px1 y1 onto this line, you know the perpendicular distance. Tell me what is the perpendicular distance? The perpendicular distance is given by AX1 plus by1 plus C divided by square root of a square plus b square. That is the perpendicular distance which we are calling it as a PM. Now what is SP? SP is equal to square root of x1 minus alpha whole square plus y1 minus beta whole square. So that is nothing but SP. But according to the definition of a conic section, SP must be equal to E into PM. SP is equals to E into PM. Now squaring on both sides, what we will get? X1 minus alpha whole square plus Y1 minus beta whole square is equals to E square into modulus of AX1 plus BY1 plus C. You can remove the modulus because we are doing squaring, whole divided by A square plus B square. Now we have to find out the locus of a point P x1 y1. For finding the locus of a point P x1 y1, in place of x1 y1 we can write x comma y. So we will get x minus alpha whole square plus y minus beta whole square is equals to E square into ax plus by plus c whole square divided by a square plus b square, that is the locus of a point P x1 y1. Now if you simplify this equation, this entire simplification of this equation definitely will get in this form: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. The simplification of this equation you will get in this form. This is the general second degree equation, right? The general second degree equation represents a different cause under different conditions. The general second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0 under the condition delta. What is delta? ABC plus 2fgh minus af square minus bg square minus ch square is equals to 0. Delta is equals to 0. This equation represents a pair of straight lines. Represents a pair of straight lines under the condition delta is equals to 0. The same we can also write it as A H G H B F G F C. Determinant is equals to 0 also we can write. Just for the remembering purpose, don't take it as seriously. Just for the remembering purpose, we can also write in this way: all hostel girls with their hostel boyfriends gone for cinema, right? So AHG, HBF, GFC determinant is equals to 0. This determinant simplification you will get ABC plus 2FGH minus AF square minus BG square minus CH square is equals to 0. The general second degree equation under this condition represent a pair of straight lines. At the same time, if delta value not equals to 0, delta not equals to 0 and A is equals to B, H is equals to 0, at the same time G square plus F square minus AC greater than or equals to 0, it represents a circle which we discussed in the beginning of the circles chapter. Delta not equals to 0, coefficient of x square is equal to coefficient of y square and H is equal to 0, G square plus F square minus AC greater than or equals to 0. The same equation represents a circle. Next, at the same time, delta not equals to 0 and H square is equals to AB. It represents a parabola. Delta not equals to 0 and H square less than AB. The equation represents an ellipse. And delta not equals to 0 and H square greater than AB. The same equation represents hyperbola, right? The general second degree equation under this condition represent two straight lines. Under this condition represent a circle. Under this condition it represents a parabola, ellipse, hyperbola, right? So first of all we are going to discuss about parabola. So what is the definition of a parabola? What we are saying here, SP is equals to PM. SP is equals to PM, then we are saying that the locus of P is a parabola. SP is equals to PM. So now this is the focus and this is the directrix. Okay. So there is a point P. The point is moving in such a way. The point P x1 y1 is moving in such a way. Its distance from a fixed point its distance from a fixed line. These two are always equal. SP is equals to PM, because here E is equals to 1 in case of a parabola. SP is equals to PM. The locus of a point P x1 y1 is a parabola, right? So now I am going to discuss the standard equation of a parabola. Sir, how we will get the standard equation of a conic? To get the standard equation of a parabola, what to do is take the principal axis as x-axis. What we have to do? Principal axis. This is the axis of a conic. Take this principal axis as a x-axis, right? So from S onto the directrix, a line is drawn perpendicularly. Let us say that is meets at Z. That means from focus onto the directrix, this is the foot of the perpendicular SZ. Let us consider the middle point of SZ, that is as origin. Consider the midpoint of SZ as origin. So passing through origin perpendicular to the principal axis, this line which we are drawing is x-axis, right? Now I am going to derive the equation of standard equation of a parabola. As I told, SZ middle point is equals to origin. I am considering SZ is equals to 2a. Or if I am considering SZ is equals to 2a, SZ total length is equals to 2a. This length is also equal to a. This length is also equal to a. Now this point is becoming a comma 0. This point becomes minus a comma 0. Now can you tell me what is the equation of this directrix? The equation of this directrix is x is equals to minus a, because this point is minus a comma 0. Therefore this line equation is x is equals to minus a. In the standard equation of a conic, in the standard equation of a parabola, we got the coordinates of the focus as a comma 0. We got the equation of the directrix as x is equal to minus a, and this point we got minus a comma 0. Now SP is equal to PM. Can anyone tell me what about this length from a point P onto the directrix? I am asking you, what about this perpendicular distance? No doubt this length is equals to a, so this length is also equal to a. But what about this length? This length is equals to, this length is equals to x1, because there is a point P x1 y1, so this length is equals to x1 and this length is equals to a. That's why the total length PM is equals to x1 plus a. SP is equals to PM. I got this PM length is equal to x1 plus a. Now what is SP? Distance between S and P. So that SP is nothing but square root of x1 minus a whole square plus y1 minus 0 whole square is equals to modulus of x1 plus a. Now squaring on both sides, we will get x1 square plus a square minus 2 times x1 into a plus y1 square is equals to x1 square plus a square plus 2ax1. Now x1 square plus a square, x1 square plus a square cancel. Then we are getting y1 square is equals to 4ax1. But we have to find out the locus of a point px1 y1. Therefore the locus of a point px1 y1 is y square is equals to 4ax. This is the standard equation of a parabola. Y square is equal to 4ax is the standard equation of a parabola. Now based on this standard equation of a parabola, y square is equal to 4ax. You can observe for this parabola y square is equal to 4ax. Equation of a parabola we got, but how was the graph for this? How to find out the graph for this? You see, y square is equals to 4ax is the standard equation of a parabola. where a greater than 0, right? The standard equation of a parabola we derived where a greater than 0. The first point what I am discussing here is if x less than 0, x value less than 0, then you will get y as imaginary. Y values you will get imaginary. The reason is whenever x values are negative, y square becomes negative. Y square becomes negative means the values of y are imaginary. So what is the meaning for that? Just from the parabola y square is equal to 4ax, I am going to draw the graph of the y square is equal to 4ax curve. Okay. So curve tracing, I am going to draw the graph of y square is equal to 4ax. So you can observe for x values negative, y values are imaginary. What is the meaning of that? For negative values of x, you won't get a graph. You won't get a graph for the negative values of x. So that is the reason there is no graph to the left of the y-axis. To the left side of y-axis there is no graph, right? Second point is when x greater than 0, you will get y value is equals to plus or minus root of 4ax. So what is the meaning for this? For positive values of x. For positive values of x. Here for positive 1 y value positive, 1 negative value. Positive negative value, 1 positive value. Negative value, 1 positive, because we are getting plus or minus. For every value of x, 1 positive exists, 1 negative exists. For every value of x, 1 negative value exists, 1 positive value exists. It means the graph is symmetric about x-axis. The graph is symmetric about x-axis. At the same time you can check y square is equals to 4ax is passing through origin also. 0, 0 substitute here, satisfying. At the same time next point is as x values are tending to infinity, no doubt the values of y is tending to plus or minus infinity. As x values are tending to infinity, y value you will get plus infinity, y value you will get minus infinity also. Based on that information, the graph of the parabola is like this, right? Passing through origin, the graph is symmetric about x-axis. For every value of x, 1 y value upward, 1 y value below the x-axis. The graph is symmetric about x-axis. At the same time, whenever x values are tending to infinity, the graph is also approaching to plus infinity and minus infinity also. So this is the graph of the parabola y square is equals to 4ax. For the parabola y square is equals to 4ax. For the parabola y square is equals to 4ax. All of you observe. We got the coordinates of the focus a comma 0. Focus we got a comma 0. Vertex where the parabola meets the principal axis is called vertex. We got vertex is equals to 0 comma 0. And this is the directrix. The equation of the directrix we got x is equals to minus a. Tell me what is the equation of the principal axis? The equation of the principal axis is y is equal to 0. X axis is the principal axis. The equation of the principal axis is y is equals to 0. Now what is this? This is a double ordinate passing through focus. This is the double ordinate passing through focus, which we will call it as latus rectum. But what about the length of the latus rectum? I am assuming this point is equal to L and this particular point is equals to L dash. But what about the length of the latus rectum? For finding the length of the latus rectum, I am assuming this length is equals to lambda. But whenever this length is equals to lambda, we know this length is equals to a. Can you say what about the coordinates of L? The L coordinates are a comma lambda. Clearly the point L lies on the parabola. So substitute that point in the parabola equation. this L point, substitute in the parabola equation. Then what we will get? Lambda square is equals to 4a into a. Therefore, we are getting lambda is equals to plus or minus 2a. Lambda is equal to plus or minus 2a we are getting. That's why this point is a comma 2a is one point. The other point becomes a comma minus 2a. So that means we got the length of the lattice rectum as this length is 2a, this length also 2a. So we are getting length of the lattice rectum is equals to 4a. End points of the lattice rectum are a comma 2a and a comma minus 2a are the ends of the lattice rectum. Ends of the lattice rectum we are calling it as L, L dash are the ends of the lattice rectum. At the same time we discussed the focal distance. SP is the focal distance. But what about SP? That length, focal distance, as we discussed earlier also. SP is equals to PM. This PM is nothing but this length is A and this length is equal to x1. That's why SP is equals to focal distance, that is nothing but x1 plus A. So for the standard equation of the parabola y square is equal to 4ax, the graph will be like this. Directrix appearing this side and vertex is 0 comma 0, focus a comma 0. The equation of directrix is x is equals to minus a. We got the vertex as 0 comma 0, right? The equation of directrix is x is equal to minus a. X axis is the principal axis. The equation of principal axis is y is equals to 0. Length of the lattice rectum is equals to 4a and the ends of the lattice rectum are a comma 2a and a comma minus 2a. Focal distance is equal to SP, that is given by x1 plus a in case of the parabola y square is equal to 4ax. Let's discuss the other standard forms of the parabola also. The other form of the parabola is y square is equal to minus 4ax. So just I'll try to discuss all the four cases in a single figure. Pay attention here. This is the first case we discussed. This is the parabola y square is equals to 4ax. For this parabola y square is equal to 4ax. Just now we discussed the focus a comma 0 and this is the directrix. The equation of the directrix is x is equals to minus a. Here there is a point p x1 y1, right? That is the point p x1 y1. SP is equals to pm, right? Focus a comma 0. Equation of directrix is x is equal to minus a. Vertex is 0 comma 0 and the length of the lattice rectum, this is called the length of the lattice rectum. The length of the lattice rectum is equals to 4a and the end points of the lattice rectum are a comma 2a and a comma minus 2a are the ends of the lattice rectum. In case of the parabola y square is equal to 4ax, at the same time focal distance is equals to SP, that is equal to x1 plus a. That is the discussion we did in the first case. Next case I am discussing, this is the another case for the parabola. So this is the another form of the parabola. This parabola equation is y square is equals to minus 4ax. Y square is equals to minus 4ax. For this parabola you will get the directrix like this. This is the directrix and here you will get the focus. That focus is equals to minus a comma 0. Focus minus a comma 0. Observe here. For this parabola we got the focus a comma 0, whereas vertex is 0 comma 0. The equation of directrix is x is equal to minus a. Whereas for this parabola focus minus a comma 0, vertex is same 0 comma 0. This is the directrix. The equation of the directrix is x is equals to a. Now can you tell me what about the length of the lattice rectum? Length of the lattice rectum is 4a only. Length of the lattice rectum 4a only, but what about the ends of the lattice rectum? This is one end of the lattice rectum, this is another end of the lattice rectum. This L is equals to minus a comma 2a, and this end point is equals to minus a comma minus 2a. So the another form of the parabola equation is y square is equal to minus 4ax. Its graph is like this: vertex 0 comma 0, focus minus a comma 0, directrix is x is equal to a to the right side of y axis. This line equation is x is equals to a. So that is the second form of the parabola. Tell me now, for this parabola, what is the axis? The equation of the principal axis is x-axis. That is nothing but y is equal to 0. So next case we are discussing So this is the another form of the parabola whose axis is y-axis. Now this parabola equation is x square is equals to 4ay. The equation of that parabola is x square is equal to 4ay. Now focus will be here. Come on, tell me here. The point is, what is the focus? You have to say the focus. Focus is equals to 0 comma a is the focus. Vertex is 0 comma 0. And this is the directrix. Can you tell me what is the equation of the directrix? The equation of the directrix is, this is the line, y is equal to minus a is the equation of the directrix. Now I can say this is the length of the lattice rectum. No doubt here also you will get the length of the lattice rectum as a 4a only. But this is the coordinates. If this point is 2a comma a, then this point becomes minus 2a comma a. These are the ends of the lattice rectum. So for the parabola x square is equal to 4ay, vertex is 0 comma 0, focus 0 comma a, ends of the lattice rectum, the equation of the directrix. Whereas for this parabola, what is the axis? The principal axis is y-axis. Y-axis is nothing but x is equal to 0. Right? Now one more parabola is there, that is open downward. So the equation of this parabola, for this parabola, the equation of this parabola is x square is equal to minus 4ay. The equation of the parabola x square is equal to minus 4ay, and this is the directrix. The equation of this directrix is y is equal to a. No doubt vertex is same, 0 comma 0 is the vertex. Focus is equals to, come on, say the focus. Here the focus is 0 comma a, but here the focus is negative side of y-axis. That's why focus is 0 comma minus a is the focus. Right? Now we can say the length of the lattice rectum is again 4a, but the ends of the lattice rectum, this side x coordinate is minus 2a comma minus a, whereas here x coordinate is 2a comma minus a. Those are the ends of the lattice rectum. These are the four standard forms of the parabola. The first one is y square is equal to 4ax, y square is equal to minus 4ax, and x square is equal to 4ay, and x square is equal to minus 4ay. These are the four standard forms of the parabola. Okay, so next class I am going to discuss applications on this. Okay, bye.